Okay, so just some recap for yesterday. Okay, we actually gone through with you guys what is the virtualization platform. Okay, so virtualization platform, we also talk about Zen platform. Then we also look into KVM platform. Okay, so all these are the software layer that will help you to virtualize the hardware itself. So over here, when we talk about virtualization, we mainly focus in the computing part, okay, for yesterday. So this is to facilitate virtual machine creation. Still remember some keyword like this. Okay, we are basically used to share the physical machine. So all these are some keywords that we actually gone through yesterday. So with the hardware equipment, we can now run multiple virtual machine hosts together. Okay. So from yesterday, we actually also cover the lab demo, where we actually do the CNA installation with ISO, this image, into the server. Then we also cover a little bit on the VRM installation with the installer too. So to be exact, the name is called the Fusion Compute Installer, .exe, for example. So the VRM is actually a push as a virtual machine template appliance into the CNA node. Okay, so these are roughly the things that we covered yesterday. And when we talk about virtualization, okay, for today, we will also cover the extra things, like for example, storage. Okay, first one, we will go through the network virtualization. Okay, just a part of it, because network virtualization is actually quite broad. Okay, so we will cover in network virtualization, most of the time will be in virtual switching part. Okay, virtual network switching. So later today, we will also cover the storage virtualization part, mainly to use storage as a pool of resources to host virtual machine disk data, okay, or what we call the VHD. Okay, so you need to remember all this data will be saved in your particular storage itself. So the virtual machine, this data, and also the config data is actually stored in the same location. Okay, they call it .xml. Okay, so later today we'll also do some demo. Okay, demo on the distributed virtual switch configuration. And we'll also demo on the remote data store connection to VRM and also CNA. Okay, so these are the things that we'll cover later on today. Okay, so let's see. Okay, numbers of participants quite high already. Okay, so these are some of the recap and also the things planned for today. So let's move on. Okay, for the first topic of today. Okay, so next thing we'll cover a bit on the network basics used in cloud computing. Okay, so the network consists of varieties of network devices in order to provide connectivity for the virtual machine and also the client to access to the virtual machine server. So in addition, traditional physical network will need to be there still. It has an interconnect equipment. And then the network for the virtualization environment also include invisible network running inside the server. So this one we'll also cover later, more in depth. Okay. This is referring to the network connection provided by your VM that are able to run within the same server themselves without any physical hardware network equipment involved. Okay. So here we'll cover basically how they actually connect within the server and also between CNA server. Okay, so let's go into it. So first we'll understand how the physical and virtual switches really works and different. Okay, then later we'll look into some architecture used in the virtualized environment, traffic flow between the VM, so how they actually looks like inside the server or even between the servers. Understand the concept related to also VLAN. So you will see that most of the technology we discussed over here will be focusing on layer 2 VLAN. Okay, so first thing, network architecture used in virtualization. Okay, so this is some of the questions that you might ask. Yesterday, we already prepared the environment, installed the physical server with the CNA software, plus join into the VRM software. So you can now manage the host and try to create virtual machine on it. So how do your virtual machine actually communicate or connect to the external equipment or the outside world? And how do they actually interconnect themselves inside the same CNA node? So you will see roughly this will be the common topology used in a data center. Okay. So you will see here, first thing on the bottom layer. Okay. So this one is basically referring to your CNA. CNA node here, and also CNA. So we are basically using a 4 CNA node environment. Okay. So the physical server here referring to your CNA hardware. And then inside you will see that there is a small tiny word telling you this is actually the virtual machine. So you will see that the virtual machine can have connection, okay, from the physical server direct to the network, or they will be interconnected with your virtual switch. Okay. So you will see that here is basically your V switch. V switch. Okay. This is actually your V switch. So this virtual switch is basically a program run inside your CNA node. And this one will able to provide the local internal network connection switching, okay, for your virtual machine. So over here, this particular virtual switch will utilize your CNA, CPU, and RAM memory for the network loading. That is why your KVM will have some overheads for this particular operation. Okay, so for this kinds of technology is pretty common in use in Huawei Fusion Compute, VMware, and even Microsoft Hyper-V. Okay, so the virtual switching here is able to interconnect VM, and if you are running on the same IP segment, your connection can basically connect to each other within the software layer. And if you would like to connect from one server to another, then you will need to go through the switch, then come to the other server itself. Okay. So over here, you will have the either your access, okay, someone they call it access, and sometimes they call it the distribution switch. Okay, depends on which name you are putting in. And we sometimes also use it, we call top of rack TR switch. Okay. So this is just used to interconnect the CNA and management. Okay. So this layer is mainly used for your CNA to communicate each other. Okay. If you are running on maybe flat layer 2 network, okay, for example. So if you are requiring layer 3 switching or routing, then you will have basically here is your core switch, for example. Okay, maybe this core switch will be your gateway, and this router might be another, okay, maybe WAN or internet gateway. Okay, so this gateway mainly for your LAN connection, okay, to provide layer 3, okay, switching capability, for example. Okay. So we'll see that over here, although a lot of communication can happen, okay, within your CNA node and also the virtual machine. So you will see that the internal connection will be used for the VM that are running on the same CNA host. If you require to connect from one VM to another, sure then you will require another physical hardware that interconnects the server physical connection itself, so that they will utilize this layer 2 network equipment or layer 2 switch to send the traffic over if they are running on the same IP segment. Okay, so if you are communicating from one IP segment to another, so I will further send my traffic from the CNA node to the layer 2 equipment, and the layer 2 equipment will then forward to the gateway that is used in your LAN connection, and the gateway will basically know how to actually connect you to the other server or network. Okay, so this is just some rough idea, okay, what it will actually looks like with this diagram. So later we'll talk about more later, again, how they actually utilize VLAN and also gateway for it to intercommunicate the virtual machine together. Okay, so from your configuration, and also I will demo certain of it later on. This particular port will be basically your okay, so this is basically your physical uplink, okay, from the CNA node to the network equipment. Okay, so this is required so that your virtual machine can utilize the external connection to connect to the outside world. So if your CNA farm is holding virtual machine server that is providing certain application service, then surely they will require the routers. Either your client is coming from another, maybe data center or network, they were able to route them to this data center to access to the virtual machine server services. Okay, so with this virtualization layer introduced to the data center, you will find that a lot of time the traffic going on will be from east to west, we call it. Okay, so this one we sometimes also call it the east to west network. Okay, so it will be a huge layer 2 and sometimes also layer 3 involved the gateway network that happens within your data center. Okay, east to west. So a lot of network capability and switching will happen within the data center. And if you are running your server VM in this one plus your VDI virtual desktop in the same data center, surely your traffic will going to grow in this east-west network traffic. Okay. Then later, if you require some extra routing function with gateway and even to another network data center, sure thing you will require to connect to the higher level equipment. So this one we sometimes call it the okay, north to south network. Okay, so you need to have all these keywords, then you know that which particular network direction that you are looking into. Okay, east to west in between CNA node, then north to south will be connecting to the outside world or required to utilize the gateway, okay, to switch to the other network, for example. Okay, so these are roughly the introduction. So you roughly know that now CNA, basically a lot of traffic will be running with the interconnection network or within the same CNA server using the virtual switching capability. Okay. So now, next thing, how your virtual machine actually connects to a different VM. So you will see that first thing here on the top left, they are still using normal network technology, broadcast, and also unicast. Now, when the virtual machine would like to look for the other VM peer, they will basically do a broadcast, okay, network broadcast. So the network broadcast will actually send the traffic to the, okay, let me go back to the earlier slide. So the broadcast will happen to the virtual switch first, okay. So the virtual switch will actually do a broadcast. Okay, if the virtual switch is connected to other VM, the broadcast will also received by other virtual machine. And then the broadcast will also get forwarded with the physical uplink to the layer 2 network equipment. And then the layer 2 network equipment will proceed to broadcast it, okay, forward the broadcast to the other server node, then to the virtual switch. So that all the other virtual machine that is connected to the same layer 2 network equipment, and if they are running on the same VLAN and segment, they will basically get the same broadcast. Okay, so the first thing first here, we're using broadcast to actually send a message. I am looking for maybe, okay, let me write down here. So this guy may be running on 10.1.1.1. I would like to connect to maybe 10.1.1.2. So I will basically broadcast who is 10.1.1.2. Okay, so I'll do a broadcast. So I will just forward this broadcast message to the virtual switch and also physical switch. Then your peer will say that, oh, I am the 10.1.1.2, for example, okay, as a response. So when they know, okay, from the sender, okay, so this is your sender, they know where is your receiver now in the network, then this will form a unicast connection. Okay, it will be one-to-one. So I'm now able to actually send the data that I require to this particular node. Okay, so backend they will also recognize your MAC address used in the layer 2. So if you are going for virtual switching, the MAC address will be assigned by the CNA virtual switch software. Okay, so these are some of the basic concepts. So if your VM is running on the same host using virtual switch, or they are running on a different host, but they actually comes from the same VLAN and also segment, your connection basically will work something similar like this, okay? With broadcast and also unicast straight away. Now, if you require to send your data or communicate with other virtual machine that comes from maybe the other data center running on another segment also, then your traffic might need to forward from a switch to the gateway, and then from the gateway to the router again. The router will help you to route it to the other data center or network. Okay, so when you actually involve communication from one data center to another via WAN link or whatsoever, then you might require a router with routing functionality. Okay. So another pretty common one in use within the same data center with layer 3 switch equipment, we can utilize a layer 3 switch other than router to act as a default gateway inside your data center network. So this is mainly using the particular equipment to send your traffic from one segment to another segment, but they are staying in the same data center. Okay. Then you do not need to have a router to connect to another router with some maybe WAN link or routing protocol and table. With a layer 3 switch equipment, you can easily do that. Sometimes we also call this as inter-VLAN routing, if you want to put it this way. Okay. Inter-VLAN routing. So this is the particular default gateway concept. So any segment that is different, they will require the default gateway to help you to switch to the other network itself, okay, using layer 3 protocol. So lastly, if you would like to isolate the network for your virtual machine, you can always implement VLAN technology, okay, or sometimes we call it the VLAN tagging function. So you will see here the CNA node that holds the virtual machine is connected to the physical network, for example. Now the virtual machine is isolated with the VLAN ID. So when the traffic comes to the switch, it will be tagged with VLAN 1, for example. Okay. Then when they tag with VLAN 1, when the data comes to this port, okay, they will not be untagged, and the VM here will not able to recognize untagged frame. Okay, so these are just some basic networking terms that we use sometimes. So over here, when you configure access port for VLAN 1, this port will able to tag and untag VLAN 1 data only. If you configure VLAN 2 access port here, they are able to tag and untag VLAN 2 data. Meaning to say when VLAN 1 frame or packet comes to this port, it will basically be unusable because your virtual machine or your client and device cannot process any tag frame. Okay? So using VLAN, you are able to communicate virtual machine from VLAN 1 to virtual machine that is also running on the same virtual LAN required sometimes, okay, VLAN. So this is a standard technology in network switching that you can always configure in the physical hardware also. Okay, so generally, with the correct configuration, VLAN 1 VM will not see traffic that is broadcast or sent by the virtual machine from VLAN 2 or even VLAN 3. So this is able to provide, okay, network isolation between the virtual machine also using the VLAN concept, okay, on the layer 2 level. Okay, so you will see this is some basic network concepts. So next thing, we move on to the physical network. So when you deploy a virtualization environment, physical network device is required. Okay, so like I mentioned just now, depends on what kinds of network connection you are designed and prepared to actually forward your traffic. So you might require routers to interconnect your data center, for example. Okay, so here. Okay, so the router here is mainly for data center to data center connection, for example. Okay, data center to data center connection. So this one will require maybe a WAN link and also your routing table. Okay, to make sure you can connect to certain data center network and sometimes even the internet. So let's see how the network design goes. Okay. Then another one, layer 3 switch, works quite similar, but this guy will be handling a internal data center L3 request, okay, mainly to perform inter-VLAN routing. Okay. It's mainly used for your LAN gateway from one internal segment IP to the other internal segments of IP. Okay, so this is the concept. Okay, so it will relate back to the big diagram that we see earlier, the topology with CNA node and the layer 2 and layer 3 equipment. Okay. So all this physical hardware is still required in order for your virtual machine to have a better external connection to certain network and provide certain services. So the layer 2 switch here will be used for your okay, normally CNA to CNA interconnect. So this guy can use for service and also management network. Okay, with a flat maybe VLAN configuration. Okay, flat VLAN configuration. So if you do not require any gateway functionality, your network will actually get switched by the layer 2 network equipment to your server hardware. So this server NIC will basically your CNA node uplink port, okay, for physical external connection. Okay. Physical external connection for your CNA uplink port. So these are the hardware required, especially for your virtual machine to have network connection, to be able to connect to the other VM and also your client user. Okay, so pretty easy on the physical network part. Okay. So routers in the virtualized environment. So the routers will require, again, in each of the data center, even enterprise offices. So the router mainly in charge of external and internal intercommunication. So from the router perspective, sometimes they also use as an internet gateway for the virtual machine to be able to connect via the router to the internet connection. So later we'll also talk about some technology like network address translation to actually make this happen, for example. Okay, so that your internal virtual machine network can actually connect to the public internet network, okay, via the router itself. Okay, so those are for routers. Then layer 3 switch in the virtualized environment. So you will see that over here, the layer 3 core switch network. Okay, so sometimes this we call also the core switch network. So all your network traffic will actually do an exchange over here. So maybe you have the management IP traffic, then you have the KVM service IP. Okay, so you have the storage IP and the client network. Okay, so this core equipment will help you to switch, okay, for example, pass and forward your data from the client service network to the management equipment, okay, to the physical server, for example. This one will be your maybe CNA management and also your CNA storage, for example. Okay. your CNA storage. So that your CNA can connect via the network to the storage equipment that we will be demoing later on in the lab, okay, just to let you have a better idea. And also the virtual machine that is running on the CNA node do have its own service traffic, okay, with different VLAN or IP segment. They're able to forward to the layer 3 equipment so that I can now, using inter-VLAN routing, to forward it to the other client network for them to intercommunicate. Okay. So the layer 3 is required, especially when you have multiple different network segments who would like to communicate with each other. Okay. So you require the layer 3 equipment here. So if you are designed to only provide internal communication between your virtual machine within the same segment and VLAN, then you don't really require a layer 3 equipment for that to work. So with this layer 2 network switches, generally your virtual machine can forward the VLAN packet or frame with this equipment and then able to be recognized by the other VM itself. Okay. So if you are using a flat network, for example, the physical server, storage device, and also user, they are all coming from one same segment, then this particular layer 2 switch will able to work. Okay, so for example here, 192.168.1. Okay, 1 to maybe 10. This guy is 192.168. Maybe 11 to like 20. And this guy is 192.168.1. Okay, dot 151 to maybe 160. All of them actually comes from the same /24 network. Then it will able to communicate with each other. Okay, and then all of them are actually under the same VLAN 1 ID, for example. Okay, so with this design, a normal layer 2 switch can get the job done. Okay, so in your environment, when you try to practice your lab, you can actually prepare and create something similar, which is easier. Then you don't need to worry where you can get a layer 3 switch equipment to act as a gateway if you do not have any. Okay, so this is running on layer 2 network entirely. So your physical network card. So the physical network card or network port runs on the CNA node. You have two options here. Okay. So this is actually your CNA NIC card. So this is running on single port perspective, non-bundle. So with minimum one port, you can have your network connection from the physical and to the logical form also. With this design, okay, it is a bare minimum for your network connection to work, but there will be no, okay, in this environment, there will be no redundancy. Okay, so we will incur a lot of SPOF, single points of failure. So these are some keywords that you will see in the documentation and also PPT sometimes. Okay. So this is the CNA node network port. If you only connect with one port, anything happens to the network cable and even the network port itself, the entire connection to the CNA node and also your virtual machine will be going down. That is why best to have a redundant port, okay, especially when you use it in the enterprise production environment. So when you have another option called the bundle, this is basically, sometimes we also call it the port aggregation. Okay, port aggregation. So here I can actually bundle these two, okay, into a logical port. Okay, So this one we can do maybe active, passive. Okay, one active, the other one used as a passive standby link, or you can even combine as a LACP. Okay, link aggregation control protocol. Okay, so if you are using active passive, it's easy to set up, and from your network switch equipment, you don't need to have any special support to run active passive. Okay, but the disadvantage here for active passive is if you put in 2 ports, it will be only 1 port active always that can send your network traffic. You cannot utilize both ports at the same time for more performance, for example. Okay, so this active passive is mainly used to protect your network connection to have redundancy only. If your network equipment on the other end that connects to your CNA node do have some added feature like LACP function, you need to configure your network switch that is connected to your CNA node to do a port aggregation on their side with LACP protocol. So we'll do it the same in your CNA node. Then these 2 sets of ports will interconnect them together. And with this control protocol, they are able to utilize both links, okay, for load balancing network traffic use. So both links will able to send their network traffic, and they can also act as a redundancy for each other. So for best performance, most of the time we will go for at least LACP, and then you will need to get an LACP for the switch in order to actually enable this feature. Okay, so after you have your physical network port ready as your uplink, so inside the uplink itself, we are basically sending multiple different traffic from logical perspective. Okay? So all these network card and ports will be shared by multiple virtual machines inside, and also used by your CNA VRM management traffic. Your CNA to storage equipment traffic sometimes also can be used, and your virtual machine service traffic. Okay, so all of them can also share the same physical port to send to different equipment. Okay, so this one will be some added notes here. Okay, let's see. So this is for your data store network. This one is for your virtual machine, and the management is for your VRM and also CNA communication. Okay. So logical perspective, they will basically able to forward a lot of different types of traffic for different use. But from physical perspective, they are just sharing the same sets of ports, okay, to the network equipment instances. Okay, so this is on the physical and IC perspective for the virtualization environment. So next thing, we move on to the virtual network for virtualization. So we roughly talk about what is the requirement for physical perspective. Now we will talk about virtual, okay, virtual network. Okay, so you will see here, this is the host machine internal view, okay, when you actually utilize the CNA software. So the host machine will refer to as a CNA. Okay, so this particular virtual switch will utilize your KVM, and then your CNA, CPU, and also RAM memory. Okay, for the common switching type that we'll discuss also later. Okay, so for your CNA node connection, okay, so you can sometimes provide direct connections, okay, to the virtual machine. If you are running on, for example, this one will be running on the hosted network, like for example, here if you go in this guy, this one will be provided with the Okay, maybe virtual box, and they can provide from the Hyper-V for bridge and also netting connection directly. Okay. So if you are running on CNA, Huawei CNA, we will require to have a virtual switch at least. Okay. So the virtual switch, it will depend on your port configuration, what types of VLAN do you have. If you set the same VLAN, then they will basically do something like a bridging connection, but they will still need to go through the virtual switch functionality. Okay, things like this. So over here, your virtual machine will have this virtual NIC card. Okay, so this is basically your okay, so this part will be your VNIC on your virtual machine. Okay, VNIC on your virtual machine. So your VNIC on your virtual machine, you can have like multiple up to, if not mistaken, 12 ports maximum. Okay, 12 ports maximum. So here you can actually configure one or multiple ports to different network that is interconnected with the virtual switch. So if they are communicating within the same VLAN and IP segment, your network connection between the virtual machine will able to actually send your traffic and connect to each other via the software we switch inside the CNA host. Okay, without the use of your uplink. Okay, without the use of your uplink. So sometimes in some testing environment, if you plan to only have internal communication, your virtual switch might not need to have a uplink also, okay, to facilitate external connection. So it depends on how you design your scenario and things. So if you're looking onto a normal production network, sure thing, this virtual switch will need to have an uplink to forward your data out from the CNA node and then to the layer 2 switch equipment list. Okay, so over here, this will be your uplink ports, your physical NIC. So you will see here, this one is basically a port aggregation, or sometimes you can also call it the port binding. Okay, port aggregation or port binding. So I am basically combine these two into one logical port, and then this will be used as your uplink to the virtual switch. Okay. So later I will show you roughly from the configuration how you actually do all this in your lab environment. Okay. So some extra concept to compare bridge and netting network, how they actually looks like. Okay. So over here you will see for your particular network here. So this is actually not bridge, this is actually your net gateway. Okay, this one stands for network address translation. Okay, network address translation. So how they actually differ is pretty easy. So you will see here, the animation will show you, okay, the data is color coded in red. And then when they send through the bridge port, the traffic will still be the same. So you will see that the external network and the internal network is basically using the same IP. Okay? So you will see here for the bridging mode. So internal, okay, this is external, for example, network, internal network. They are basically holding the same segment, for example. Okay, so this is also the same segment. Then this is what we call bridging mode. You don't do any extra network capability whatsoever. We are just passing through. Okay, so sometimes we also call this as a pass-through functionality. So anything that is running in the external, it will also be running in the internal. So your IP address is basically the same. That's why your traffic that's sending out does not have any changes whatsoever. Okay, so this is called bridging. So if you have a network address translation options, so you'll see that the data in color coded earlier is sent in red, and then when they go out from the net gateway, it will be in blue. So this is facilitating to use to have different network. For example, here 192.168.1.0. This one maybe it is a public internet IP. Dot maybe 200, for example. So this is public internet. I just use this as an example. Okay. So I will do a translation from the internal in the net gateway, translate it to an external IP, and then send over to the other network, to the public internet, for example. Okay. So it depends on what kinds of connection that you would like to achieve and how you want to control your network segment. So if you're going for bridging, basically there is no control whatsoever. Okay. Anything that works in external, it will be the same in internal. Everybody can actually connect via the port to the external part. If you're going for netting itself, here they will do some address translation, and then you can further control maybe some of the equipment do not able to utilize the net function. Okay, so this is just some basic. Okay, in our syllabus, we don't really implement this feature in our lab itself. Okay, just some concept over here to let you know. Okay, so other standard tag will be the open vSwitch. Okay, so if you require a vSwitch functionality, open vSwitch is used by KVM also. Okay, this is a open source vSwitch software. So open vSwitch can provide VLAN functionality, isolation, and traffic filtering. They can also provide monitoring function that you can check what happened and what kinds of traffic actually sending from the VM to the vSwitch. You can also do network traffic shipping using QoS. Okay, and it is actually supported by a lot of different management protocol. Okay. So if you are using a native KVM, then you will see the Open vSwitch in the picture. So the Open vSwitch is generally utilized in KVM and sometimes even OpenStack solution. Okay. So OpenStack can able to control Open vSwitch to do certain configuration via the neutron module. So another concept here is called the distributed virtual switch. Now, if you require to interconnect your network connection from one CNA to another, you will require a physical uplink, and then the physical uplink will then connect to this particular DVS. Okay. So this is actually your what we call the distributed virtual switch, DVS. So all this is your CNA host uplink. So you're able to configure a virtual layer here to tell the system this uplink is basically connected to the same. Okay, you can call it the, okay, I will put it this term, virtual stack switch. Okay, virtual stack switch. So you are basically stacking, okay, your virtual switch from multiple host machine into one big virtual switch. Okay, we call it DVS, so that your communication can happen between hosts itself. So when I configure, for example, here to maybe allow VLAN 1, so all the hosts were able to get this VLAN tag and proceed to assign to their virtual machine, for example. Okay, so this is the DVS concept. Virtual switch will only use within the same host machine. And if you would like to communicate between each other in the same network, consider that it will require the distributed virtual switch. So you can put it this way into a normal network equipment perspective. It is considered like a stack switch concept. So you are stacking multiple switch from the host machine into one big equipment. Okay? so that all your configuration will be standardized here. When you configure certain things, it will get reflected in all your host machine. Okay, so in Huawei Fusion Compute, we do not have vSwitch. Huawei Fusion Compute only support distributed virtual switch. If you compare like VMware you can basically create vSwitch or a distributed virtual switch. Depends on how you want to utilize it. Okay? For VMware, the distributed virtual switch require vCenter component. Okay? If not, you cannot create it, and most probably it will be a paid version sometimes. Okay? So if you only run virtual machine in the same ESX machine, then you will only require vSwitch. Okay, so those are the concept for physical and virtual. Then lastly, a few things. We will talk about the network feature for Huawei Fusion Compute Virtualization Platform. Okay, so in Huawei, what are the things do they actually provide? It has a network connection. So you will see here, this is basically your, okay, so over here, we'll say this is your DVS. Okay, it's a stack switch, I will say. So this is actually your layer 3 switch. Okay, or you can also call this as a gateway. Okay, gateway. Now I actually didn't show you where is the layer 2. The layer 2 switch will just use as a forwarding. I will just keep it. So I straight away show you the layer 3 switch itself. So how your traffic flow will actually go through. So you will see here, when you have virtual machine running in the same CNA host, yeah. So in your virtual machine, we can isolate them with the VLAN. Yeah. So the VLAN tag will configure into the port group perspective. The port group will be used to connect to the virtual machine. So we'll see that the VM in the same host here cannot actually communicate with each other, especially for this VM and this VM. Now, for the Windows VM here, they are able to do internal communication with the Red Hat Linux VM because this virtual machine do have another network connection to the same port group with the same VLAN ID. So this Windows VM can now do internal communication to this particular virtual machine without going through the physical hardware. Okay, so this is the idea. So if you are providing local internal network, then your DVS will able to get the job done, okay? At least for these two virtual machine connection. So you will see here in this particular diagram, you have virtual machine connected to VLAN 100 in host machine 1. Then you have another VM connected to VLAN 100 in the host machine 2. So this host machine is basically referring to your okay, CNA node 1, for example, then CNA node 2. Okay, pretty easy. So in order for them to actually communicate each other, they will require the extra physical hardware, okay, either layer 3 or layer 2 equipment. So you will see that here from the virtual machine that requires to communicate to the other VLAN network. So here you will require what they call the gateway function. Okay, gateway function to route you from one network to another. So this is to provide what they call sometimes the inter-VLAN routing. Okay, just to route between VLAN internally. So it's actually internal network to internal network. Doesn't have anything to do with your external WAN link network and sort of. Okay. Now, if you have another traffic flow, for example, from VLAN 300 to another VLAN 300 machine, they will happen internally, okay, without the needs of your physical hardware. And lastly, if you would like to communicate from one VM in host machine 1 to another VM in host machine 2, running on the same VLAN, here we will just require a layer 2 switching. So I'm basically forwarding the data frame or packet to the other host for them to process. Okay, So this one will basically perform something like broadcast and then later unicast for the traffic flow. Okay, so this is for how your network traffic will be happening for your virtual machine inside the CNA node itself. Okay. So there is another feature called the security group. So inside your CNA node, you can further define some network access rule with different rule configuration to actually prohibit, okay, your virtual machine to connect to the other VM. Okay, so in your security group, you can define something like this. VM1, okay, cannot connect. Or you can also call it deny sometimes to VM2. Although the virtual machine, okay, might be coming from the same segment, .1.1. This guy is 192.168.1.2, for example. Now with this rule in place, you are not able to connect to each other. Using security group, you can do something like this. So they will give you an extra security control that can even apply within the same VLAN. So from VLAN perspective, these two virtual machines should be able to communicate with each other, but because you also assign a security group rule here, telling them that VM1 should not connect to VM2, although they come from the same segment and the same VLAN, they will still prohibited to see each other, things like this, okay, using security group. So this is another software control layer on the security part in the virtualization network in Huawei Fusion Compute. Okay, so you can utilize the rules to block them up. And there goes the network virtualization topic. Okay, so I hope you actually understand how the network works in the CNA node. All these things. Okay, so there goes the first topic. Okay, so it's kind of lengthy for the theory. I will actually do a short break now for you guys to rest a while. Okay, so I will start again. Malaysia time, 9:20 p.m. Okay. Okay, so let's continue again. Okay, some of you asked me to recap the Open vSwitch concept. So remember this Open vSwitch. Okay, this is the open source vSwitch functionality. Okay. It's open source solution. So it's kind of pretty common in use in a lot of platforms. Okay. So like for example, KVM is using it. It's just a software to provide virtual switching facility. Okay. So Open vSwitch can provide security VLAN, isolation like traffic filtering, QoS function to traffic shape your things, like also port monitoring, etc. Now, this is also being able to okay, manage and control by the OpenStack Neutron component. Okay, so this is one of the things used in the KVM plus OpenStack solution in Huawei. Okay, Huawei OpenStack plus KVM solution. Okay. So if you go for Huawei Fusion Compute, okay, they are using enhanced distributed vSwitch. Okay, they did not really disclose which software they're using, but in Fusion Compute, the one where we are focusing, we are basically using distributed vSwitch or DVS. Okay, we are not using, for example, Open vSwitch in the technology. But if you advance further to HCIP training or even HCIE training, when you touch on the OpenStack plus KVM solution, then you will also start to see the Open vSwitch concept. Okay, so this is just another virtual switching software that can help you to intercommunicate your virtual machine together. So this is just some basic introduction. So as you mentioned in the Fusion Computer, we have only the DVS, okay, distributed virtual switch. Okay, so those are for the network part. Okay, so next thing. Okay, so next topic, we will move on to the storage virtualization basic. Okay. So the storage is pretty important in the IT data center now, because most of the time in IT, we will focus in data set. Okay? So now data has become an enterprise most important asset. Your virtual machine, virtual disk is holding application data like databases or even email exchange server data, for example, is super important nowadays to business. Okay? A lot of time when the IT system is down, some company, they cannot even continue their business to work, things like this. That's why data is super important, and how the data is stored in the cloud or in virtualization, we will also look into that. Okay? So how is it differ from traditional IT infrastructure? So this particular chapter will focus on all these things. Okay. So this topic objective will be looking into Huawei Fusion Sphere virtualization in the storage portion. Then we'll also see some architecture used in the virtualization environment, later different disk, okay, that is available in the IT market. Now, all this will be also asked in your exam, okay, especially your written exam. Okay, your written exam. So next thing will be differences between the centralized and distributed storage. Then what is the difference between virtualized and non-virtualized storage on your data store? We will discuss on this also. Lastly will be the virtual VM disk and the virtualization product from Huawei. What is the storage feature that they can provide. Okay? First thing, storage architecture. Now, how do the storage resources used by virtual machine come from? Okay, so this is the question. So I already discussed briefly your virtual machine, what kinds of things do they actually have in a folder? So by default, they will have at least your XML configuration file and also your VHD data disk. So where do you actually store this kind of data? In virtualization environment, so that you are able to share by multiple hosts to actually run that VM. Okay, so let's see how do they actually access the underlying resources for storage system at least. So you will see here, this is the storage architecture for virtualization. Okay, so there will be a difference between, okay, on the left and on the right. Okay, so this is referring to your virtualized storage and also non-virtualized storage. Now, these two parts we are referring to the data store. Okay, data store. Okay, data store. Now, if you're using virtualized storage, okay, so your VM disk format will be something like this. Okay? Based on different virtualization platform, your virtual disk format will be a bit different. So you will have the .qcow, okay, QCOW, that is used for native KVM. Okay. This is used for VMware. This is used for maybe Hyper-V and also Huawei. Things like this. Okay. So these are the few common ones. So it will require to actually deploy the file system. Okay. So in Huawei, they call it the VIMS. Okay, they will discuss later also. Okay, this one stands for Virtual Image Management System. Okay. VMware, they call it the VMFS. Okay, that's for VMware. So this is for Huawei. Okay, Huawei. Now this is on the virtualized storage. Okay, so on the right you will see if you are using a non-virtualized data store. So initially they will basically create this as a LUN or volume. Then this will actually mount to the virtual machine directly. Okay, similar like raw disk mapping technology. Okay, RDM. Okay, raw disk mapping. Okay, so in the non-virtualized solution here, we will actually support Huawei Fusion Storage integration. Okay, so if you are using Fusion Storage volume for your data store, you will have configuration like this. Okay, another one will be the advanced SAN storage. Okay, using the SMIS protocol. Then you will have the non-virtualized storage. Okay. So this is another types of configuration if you integrate it to Fusion Storage. Okay, with Huawei Fusion Compute. Now this is not really common. Okay. So the more common one will be the virtualized storage. So over here, we will require to format it with a file system. Okay, and we do able to support FC SAN, IP SAN, okay, NFS, and also local disk. Okay, and also local disk. So these are the few storage types that can be used for virtualized storage or data store. So initially from the storage device perspective, they look something like this. Okay. So I will have a physical drive resources. Okay, physical drive resources similar. And the physical drive resources will then combine into a storage pool with RAID configuration. Okay, RAID configuration. Then later depends on whether it is a SAN storage system that I will further create a logical division called the volume or LUN here. So the LUN will be mounted to the CNA node and they will format the file system there. Or you can also create a NAS share file system that can provide NFS share to the CNA node. Okay? So when CNA node have the NFS share and the LUN to be used, they can actually format and utilize it with VIMS file system. Okay, so when you create a virtual machine disk, in Huawei, they will be using .hd format. Okay? So non-virtualized storage will be referring to fusion storage and advanced storage that will be using RDM concept. Okay, so next thing will be the conversion path in the cloud computing. So you will see here on your storage device, you have physical drive. Okay? Either you configure a RAID group in it with RAID configuration. Okay, or some distributed storage, they are using replication method to replicate your data copies. And this disk will be combined into a volume. Okay, then the volume can now divide into logical division, for example, so that you can have smaller volume and LUN resources. Okay, so over here you will see this is maybe your storage pool resource. Okay, so this one will be your LUN. Okay, or sometimes you also call it full call logical unit number. Okay, logical unit number LUN. So this LUN is basically like a logical volume. Or you can also utilize the storage pool to create a file system. Okay, so you will see here, these are the two differences. One is actually using SAN-based connection storage. Another is using NAS file share. Okay, this one you can also call it file space access. This one is actually called a log base. Okay, log base. So these are the two major differences, okay, that can be used. So you attach it to your computer cluster, okay, mainly to your CNA node. So when you basically connect to a CNA host, they will then format it with a virtual file system that you can also call this as your VIMS file system. VIMS file system. So from your share category, so here you will actually put in your particular VHD over here and also your XML file. So this will be your virtual machine data. Okay, virtual machine data. So in the folder, you will have your XML configuration file and also the VHD virtual disk. Okay, pretty easy on the relationship. So for non-virtualized storage, when they connect to your CNA host, it will look something over here. It's a bit different. Okay. So first thing, your disk will be having RAID protection or replication. Then they will combine into a resource pool using physical drive, okay, to be a big, huge physical resource pool. Then you can also further create volumes, okay, either a LUN or volume. So the volume will be mounted to the CNA host, okay, the computer cluster. And when you create a virtual machine disk, Okay, this is basically your VM disk, but they are in raw disk mapping concept, RDM kind of format. Okay, RDM kind of format. So this is basically a LUN volume type. Okay, LUN volume type to your virtual machine. So this one will be used with your VM XML file together. Okay, so this one will actually form your VM folder. Okay, it's a bit different using non-virtualized storage. Okay, so this is the concept as compared to the virtualized storage system. Okay, using the data store itself. Okay, so those are some introduction to the storage architecture for virtualization. So next we move on to certain physical disk type and related techniques. Okay, so you will see here first types of disk called SATA. Okay. SATA is basically referring to the connection type over here. Okay. So this is actually your SATA connection. So SATA is full name called Serial Advanced Technology Attachment. It is also called Serial ATA. Is the newly upgraded mode of your ATA disk interface technology. Okay. So last time we have the PATA, okay, what we call parallel ATA. It is also called IDE connection using ribbon cable. Okay, pretty old types of drive connection. So the SATA itself comes with a few different types of disk. Okay. So if you go for in SATA drive, so SATA now come with version 3 that they can go up to 6 gigabit per second speed connections. Okay. So for SATA, it comes with spindle drive, okay, with 7.2K RPM. SATA also come with SSD drive. Okay. So you will see that over here, your spindle drive actually bottleneck by RPM in performance. Okay, in performance. So in the storage system nowadays, for enterprise storage, you can purchase SATA disk, okay, to populate your storage equipment. Then as a SATA disk, you can choose from either spindle drive, 7.2K RPM. Okay, so this is the normal mechanical drive that you have, okay, high capacity, okay, but it will be lower performance, okay, and cheaper in cost. SSD, also using SATA interface, they provide high performance, okay, high capacity now also, but expensive. Okay, expensive. So in order to utilize SSD drive, you might need to put in a lot more extra investment costs in order for your storage system to be faster. Now, the SATA is the interface used for the drive and generally for your performance. Okay. For spindle drive, you can get up to like 50 megabyte per second maximum, okay, due to the RPM bottleneck. Okay, so here I will just roughly introduce some basic here. Do not want to go too in depth. So for SSD SATA, they can go up to 550 megabyte per second read, and sometimes also write performance. Depends on which types of SSD you are running from. Okay. So SATA spindle drive and SATA SSD is available. running at 550 megabyte per second throughput. Okay. As compared to SATA disk, you will see that the performance is like almost 11 times more. Okay, so this is referring to SATA, but it is still available because the interface is slower, whereby capacity is also higher when you use mechanical drive. It will basically fit the cheaper solution rank. Okay, so when you look for cheaper storage solution, per gigabyte cost count, SATA will give you more capacity, okay, with the same investment. So another one we call the serial attached SCSI. So when you see the serial attached SCSI is more commonly used in the server environment. Because of the interface, they actually introduce some extra own management intelligence on the device. They will give you more benefit in performance. So over here, if you compare SAS and SATA, okay, so SAS will have lower latency performance. Okay, lower latency performance. So SATA will be a bit higher, okay, when you talk about latency. Then, if you go back to the drive that we discussed just now, okay, so you will have SAS version 3. The current now, it will be 12 gigabit per second throughput. Okay, so if you buy SAS spindle drive, yeah, they will basically pump up to 10K RPM. Okay, 10K RPM. But the spindle drive, based on their design, it is still bottlenecked by the RPM itself. Okay, so this guy will be low capacity. Okay, higher performance than SATA spindle. Okay, you need to be exact here. It's SATA spindle drive. Okay, and it is more expensive. Okay, for SAS. So generally for your SAS spindle, you can get up to maybe sometimes almost 25–30% more performance, maybe up to 80 megabyte per second with RPM bottleneck performance. Okay, so when you actually increase the RPM, you will get more performance from that. But generally speaking, 10K RPM is currently the max supported now. Last time when they are using SAS drive, they can actually pump up to 15K RPM. Okay, so with 15K RPM, it is requiring more power, and the disk size will be in 3.5-inch bigger drive. So the particular power to performance ratio is not really high. And generally, when you increase the RPM on the disk, it will also affect the lifespan of it. That's why generally for more stable performance and lifespan count, 10K is the suitable one. But due to the RPM nature, your performance is actually bottleneck. Okay? So for SAS connection, you can also purchase SSD drive, okay, using SAS connection. This one similar. They can provide high performance, high capacity, but it will be expensive. Okay, and they can achieve up to like 1.2 gigabyte per second read on also write performance, depends on which particular models of SSD. Okay, so the SAS and SATA is mainly referring to the interface itself. Okay, so this is the SAS drive, very popular in server and enterprise storage environment in the IT market. Okay, so next thing will be the nearline SAS. Okay, so when you look into nearline SAS, they are basically considered as a hybrid, whereby they actually install the SAS interface into the SATA drive. Okay, SATA spindle to be exact. So your SATA drive will able to utilize SAS connector, okay, to lower the latency, okay, on the connection type. But your nearline SAS will still have bottleneck running on 7.2K RPM. So generally speaking, the performance for nearline SAS will be a bit higher than SATA, but it is still lower compared to a 10K SAS drive. Okay, so the nearline SAS disk is also available. Okay, it's a bit more expensive as compared to SATA drive. And this one will give you capacity similar like SATA 7.2K spindle, and also certain latency benefit from SAS. Okay, so in the storage system, more or less you will see the nearline SAS disk actually provided in this storage device mode. So SSD, like I already showed just now, okay, it's called solid state disk. So in this drive itself, inside there is a flash chip, okay, and Huawei actually developed their own SSD, as you can see from the photo. Okay, SSD that is sold by Huawei actually comes with their own brand. Okay, come with their own brand. So if you purchase Huawei SSD, okay, so in Huawei server and storage system, you can purchase only the Huawei SSD brand. So they are in charge with, okay, Huawei SSD controller development. Okay, so the controller is designed by Huawei, so the software enhancement, everything will be a bit better for Huawei equipment integration. So they are sourcing, okay, your actual NAND flash from Micron and also Samsung. Okay, so Huawei assemble SSD on their own. Okay, so Huawei only in charge of the SSD controller, which actually matters in performance and also your wear and tear calculation to improve overall SSD lifespan and also your SSD performance, okay, with their own application integration. NAND flash is basically used for your capacity storage only. Okay, so this chip they actually source from the other vendor, Micron and Samsung. These two actually produce a lot of RAM memory and even some flash chip in the market. Then Huawei actually get these parts and assemble in their own factory. So as compared to the vendor pricing, Huawei SSD actually costs a little bit lower as compared to other major brands like Western D and Seagate, etc. Okay. So for the SSD, inside they will have a DRAM chip. Okay, they come with a RAM memory inside has a cache. Okay, to improve overall read and write performance also on the SSD part. So the SSD generally can increase up to a pretty huge performance counter. So generally we are now, okay, basically bottlenecked by the interface use. So if you go for SATA SSD, they can go up to like 550 megabyte per second throughput. If you go for SAS SSD, they can go up to like 1.2 gigabyte per second performance. Okay, so you do have other types like a NVMe SSD. They can go up to 3.2 gigabyte per second also. Okay, and then you have another type called PCIe SSD. NVMe is actually the longer connection types of PCIe. So PCIe SSD is basically an SSD card that you can slot into the motherboard directly. So maximum in the market, they can go up to like 15 gigabyte per second. Okay, so this one you can check the Aorus model. Okay, this is the gaming spec SSD. Okay, as a tech trainer, we always will look into all these figures to see how fast they can actually go. Imagine the PCI SSD can give you 15 gigabytes of data per second throughput, read and write. So in order for you to copy a 4K video into this SSD, maybe for a few 10 terabyte, you just require a few minutes time, okay, in order to do that. So you will see that for your SSD performance, we are basically bottlenecked by the interface use. Okay. And as the speed goes up, your SSD will cost you even higher, okay, in your investment. So SSD is pretty common in the high performance layer nowadays in the IT world. And generally the cost of it is still pretty high. Okay, although the pricing is actually reducing, but as compared to normal spindle drive like SATA and ELSAs, cost per gigabyte to invest in capacity, hard disk will still give you the benefits of high capacity part. Okay, so differences in terms of performance and pricing. So you will see that your SSD is actually here. As you can see, it is way higher than your hard drive itself. Okay, so this is for the physical drive part. So next thing will be centralized storage and distributed storage. So centralized storage, initially it is referring to your enterprise storage system. Okay, so most of the time here, this one will be referring to your either a SAN storage, or maybe it is a NAS storage. Okay, so all your data will be putting here. Okay, so your host server can connect to the storage, okay, as a centralized equipment. So the drive from the storage system will actually configure a RAID to protect this data with drive redundancy, etc., and error checking, so that I can provide a logical resource pool. And this logical storage pool or LAN resources will be shared by multiple CNA node, for example. Okay. So when they are doing a data read, right, they are sharing the same hardware, but they are owning different data set. So over here, generally, we can basically share the capacity here. Maybe I have like 100 TB. So from here, I can actually share, for example, this guy actually own 10 TB. Then I can actually own 5 TB here to be used by the server, 5 TB, and this guy maybe 15 TB, for example. Okay. So this is the normal centralized storage usage for your physical server to write your data into it. Now, from the capacity perspective, this guy can actually pull into a very huge capacity of usable, which your normal server might not be able to provide. So this is the main benefit using an enterprise centralized storage, so that you can get more capacity plus higher performance on this equipment. So this centralized storage actually also comes with its own CPU, RAM memory, and things like this, okay? And also your network card. So it is pretty faster as compared to a single disk drive that is used in your normal individual physical server disk. Okay, so if you are looking onto your HDD here, HDD, so maybe here you can populate up to like 10 or 24 disks. Okay, this guy can go up to like 1,000 disks in one equipment. Okay, so these are some of the benefits for centralized storage, and the performance offered using multiple drive will be even higher as compared to individual disks. So the cost to implement the centralized storage will not be cheap, but they generally give you a lot of extra benefit in your investment. Okay, RAID technology is pretty common in use for your server and even storage equipment. So using a RAID technology to combine multiple drives, they can give you a parallel read-write performance, as you can see here. So you can combine multiple drives to work parallelly to provide better read and write performance together. And certain read configuration will able to provide parity error check. For example, if you have any failed disk, your data will still be available. And they are able to recover from the lost data using the remaining data as a parity calculation check or mirror disk concept. Okay, so let's look into it more in depth. So generally for the normal RAID configuration available in the market, you will see that RAID 0 will be combining multiple drives for more performance only. As you can see from the drive level, the data is actually unique. So if you're using RAID 0 itself, your data can write to both disks simultaneously to improve overall performance. So if one disk can give you like 50 megabytes per second, if you configure a RAID 0 here, you can theoretically get up to 100 megabytes per second performance. Okay. But RAID 0 is mainly designed for performance improvement. They don't give you any security and data protection whatsoever. So you can move on. If you are running on enterprise environment, you need at least RAID 1. So when you configure a RAID 1 RAID group, you see that this 1 and 2 actually store the same data set. This is what we call the mirror disk. Okay. So these two is combined. This two is also combined into a logical disk. So for RAID 1, you see that the block used is still the same. Okay. So generally, this one will be combining all the capacity that you have in your particular drive. For example, here 1 TB, here 1 TB, then you will actually get 2 TB usable here. So if you compare to RAID 1, because they are only doing mirroring, so this logical drive will only have 1 TB usable. The other drive is mainly used for as a data backup. So if you're using RAID 1 configuration, if the drive actually fails, there is another drive in the RAID group that can serve you the data. Okay? So when you replace the disk, your data reconstruction will actually copy the data from these two to this one again to rebuild it. Okay? To make sure they have like 2 disk redundancy here. Okay? So another one will be RAID 5 configuration. So for RAID 5, here I will also able to give you extra performance. So the capacity will work something like this. So if you have like 1 TB per drive, your logical disk here will have 2 TB usable. Okay. So the 1 TB is mainly used for your parity check to provide data protection. Okay. Parity check for data protection. So the RAID 5 configuration will be something similar to 2 data disks plus 1 parity capacity disk concept. Okay. So using RAID 5, you will get some performance benefit when you're writing the data to multiple drives. You will need to calculate the extra parity block to protect these groups of data. So when you're writing the data, it will be a bit faster as compared to one drive, but it will be slower as compared to RAID 0. And when you read the data from the RAID 5 RAID group, the reading performance will be similar to RAID 0 without any penalty. Things. Okay, so next thing will be RAID 6. So RAID 6 works quite similar like RAID 5. So you have 1 TB here, 1 TB again, 1 TB, and another 1 TB. So here it will be total 2 TB usable only, because this is looking into 2 data disk plus 2 parity disk concept. Okay, so I can support up to 2 disk failure. Okay, so this one you can support 1 disk failure, and this one you can support 1 disk failure. Okay, 1 disk failure. So this is the concept. Okay. So in order to protect more disk failure, you will need to sacrifice a lot more capacity for error checking part. So you will see that I actually introduced 4 1 terabyte disks, but in actual fact, I can only get 2 terabytes of usable capacity. So using RAID, you can protect your data, increase the performance, but in the cost of usable capacity. Okay, so that is why when you purchase a storage, excuse me, can you mute your mic?
Yes.
Just a moment. Okay, thank you. Okay, so let's continue. Now that's why when you purchase an enterprise storage, okay, you will have a raw capacity figure. Then after you configure RAID over there, you will have the actual usable capacity shown. Okay. So it will generally depend on which RAID level that you actually choose to offer. So it will be quite some loss in your usable capacity as an investment. Okay. So for centralized storage type, you will see we have SAN and also NAS environment. So SAN is utilizing IP network connection or FC, and your NAS will be using as a file share folder, okay, to actually share your file like a normal file server types. So as you can see here, the differences between IP SAN and FC SAN. So how does it differ? Okay, so for IP SAN, okay, using HCIA protocol, we require a basic TCP/IP Ethernet switch to actually interconnect the server and the storage device. Okay, so using HCIA, any 1G equipment and above can get the job done, but due to the TCP/IP connection nature, HCIA storage system will give you higher latency performance issue. Okay. So generally, as compared to FC, HCIA will be cheaper to implement because cost for the network card and the Ethernet switch is much more lower as compared to FC. Okay. So using HCIA, because of the TCP nature, performance will be lower. And if you go for FC, okay, you will require to purchase FC switches, fiber channel switch, fiber channel HBA on the server, and also fiber channel HBA card and port on the storage device. So using fiber channel equipment, you will need to put in more investment money in order to support this infrastructure. Now using FC, the data sending protocol works quite similar like UDP, okay, whereby the storage system and the server, the receiver and sender will agree with n numbers of data frame amount. Then the server will just send straight away sequentially on all these data frames at the same time. Okay? Similar like UDP, I will not actually get an acknowledgement by per packet or per frame basis. So in turns, FC will give you lower latency performance. IP SAN will always give you a bit higher in latency performance. Okay. So when you look into storage system performance, latency is also another figure that we always look into. So due to the performance on latency, IP SAN generally will give you lower IOPS number count. FC SAN will give you higher IOPS number. Okay, so you will see here, let me just write down some extra notes here. Okay, so for IP SAN, this is higher latency. FC SAN will be lower latency. So IP SAN will also give you lower IOPS or IOPS. Then your FC SAN will give you higher IOPS. So this one stands for input output operation per second. Okay, IOPS, input output operation per second. Okay, IOPS, which is a pretty common number to measure storage performance. Okay, so generally IPsend is still in the picture because of the overall implementation cost, which is way cheaper as compared to FC. So performance as compared to both, FCSend will always pioneer when you're looking onto low latency multi input output access that is suitable for databases application, for example, and also high transaction and change server email equipment. Okay, things like this. So these are generally the differences between IPsend and FCSend. Then we can also utilize NAS storage system for your data store. So for Huawei Fusion Compute, you can utilize NFS as your data store. Okay, so your equipment will be combining multiple disks or volume into a resource pool, then create a file system on it, and later share this file system in different protocol to different server type. Okay, so you will see that CIFS stands for Common Internet File System. All this will be asked in your written exam, basically, so you need to read through the material. So CFS, called Common Internet File System, it is a shared open file system developed from Microsoft Server Message Block. So when you are trying to share data to Windows machine, so the protocol used is either called CFS, and sometimes we also call it SMB, Server Message Block. Okay, so depends on your NAS equipment, which particular terminology do they use. Okay. So in Windows OS, when you are trying to share something, you will only support this NFS as their native sharing protocol. Okay. But nowadays, due to the flexibility of your operating system, even Windows can support to share as NFS or even connect to another NFS share if you want to. Okay. But if you compare to the other equipment like VMware and also Fusion Compute environment, we only support NFS share folder to use as a data store. Okay. So NFS is short for Network File System. It's originally developed by Sun Microsystem. Okay. Sun Microsystem is still there. It's now under Oracle, if not mistaken. Okay. So it is used by Unix-based operating system to share your files. So Linux, AIX, all these platforms actually built from Unix itself. Even VMware and also Fusion Compute, they are using Unix family platform, basically. So all these platforms will be supporting NFS as their native sharing protocol to access a centralized file share location. Okay. So you will see that for CFS and NFS, these are some of the traditional feature comparison. Yeah. So this particular feature comparison is not really accurate anymore, especially when you look into the other version, like for example, okay, so these two protocol already upgraded for quite some time here. This guy now come with SMB version 3 and also NFS version 4. Okay, so with this particular version, they actually solve your error correction things and also your file conversion, all this issue that already actually able to upgrade in the SMB version 3 functionality. Okay, so this particular comparison is more towards older versions of CIFS and NFS. Okay, so next thing will be the distributed storage system. Okay, distributed storage. So as compared to the centralized storage, the distributed storage will basically combine all your okay, so your local disk on server, okay, local disk on server, So they will be pulling your hard disk, okay, from multiple server into a joint resource pool. Okay, so from the joint resource pool, I can utilize replication here to provide parallel performance and also data protection, okay, on failed disk. Okay, then I can create a volume here to be used by multiple server. Okay, so this technology is actually used by, okay, VMware, Descent, okay, Huawei, okay, not Fusion Storage, okay, it is called a Fusion Storage, not Fusion Compute, sorry about that. So another one will be Microsoft Storage Space Direct, okay, Storage Space Direct. These are the few common ones, and you will also see a storage called CEPH. Okay, this is open source solution. Okay, that you also see in the later slide. Okay. So the distributed storage architecture is quite similar for all these types of storage technology solution. So they are basically using replication to, okay, make multiple copies of your data and store it to different disks itself. So initially, when you dump in file one document into the storage, they will have the data written into this number one and then keep another copy in the other two more drive to facilitate to actually protect your data up to 2 disk failure. Okay, so in the event of this failure, you will see that your data still available from other disks, that you can access it, and they will further make a copy to protect it again using replication. So this one, sometimes you will also call it the okay, there are a few names here. Sometimes you will also use as the, okay, erasure code, okay, erasure code, and also sometimes they also call it the distributed rate, okay, distributed rate. It is quite common in use in distributed storage technology. Okay, so the capacity usage, it will be lowered because they will need to reserve a lot of space for your extra data copy to protect it. So when you're reading your data, it will be served by multiple drive or node at the same time to support multiple concurrent connection. Okay. So another two more popular distributed storage will be SAP, like I mentioned just now, CEPH, and also Hadoop file system, okay, HDFS. So initially, HDFS is mainly used for big data storage analysis, for example. So it's pretty popular also from there. So they are basically built from the same distributed storage architecture in your data protection using replication. So another one will be Huawei Fusion Storage and also VMware vSAN. Okay, so those are for the centralized storage and the distributed storage. Okay, so we have a few more things. I think I will suggest a short break here before I continue again. Okay. Another short break for 15 minutes. I will start again around 10:30. Okay, so that you guys will not be too tiring. Okay, short break again. Then we'll start Malaysia time 10:30.
Yeah, that's yes.
Okay, so let's continue again. Need to cover the remaining slides. Okay, so next thing, just some recap on the virtualized storage and the non-virtualized storage perspective. So you will see here, the disk will be used as a volume. And then I will mount the logical volume to the okay, format to a CNA node. Okay. So this is actually mounted to the CNA. And this MFS also connect to the CNA. Okay. So this will be used as the data store volume. This will also be used as a data store. Okay, will be used for your virtual machine data store. So attach your CNA computer cluster. So this is your virtual file system, and it will be used as the share catalog for your virtual machine. Okay. So another time, repeat for your non-virtualized storage. So I will create the LUN to mount to your virtual machine. Okay, so next thing will be the RAID and LUN relationship. So the RAID array is basically a combination of groups of drive. Okay. So these groups of drive can combine into a large capacity. Okay. So you can create one or more logical unit or a volume, sometimes you call it. This logical unit is called the logical unit number or LUNs that can be mapped to the CNA host or server host as a basic block device. So when you map the LUN to the server host, the server will able to detect it like your internal drive in your disk management. Then I can proceed to use this drive as a block device storage, format a file system on it, and utilize the capacity. So creating a LUN, referring to your storage system. Okay, so I will combine this into your RAID configuration. So if you're using an internal server RAID card, this will be your server hard disk. Okay, let me just put it down here. Okay, so this one can be your server hard disk or your storage hard disk. Then I will utilize a RAID configuration. So this one require maybe a RAID card. Okay, maybe hardware or software sometimes. Okay, so I RAID combine the disk into a big volume with performance improvements and data protection. Then from there, I will create smaller logical volume or LUNs. Okay, then the LUNs can be mounted to any physical server or virtual machine if you want to. So common types of file system. So you will see here the virtual cluster file system here referring to okay, VMware, DMFS. Then you have Huawei, they are using called the VIMS. Then you have the Microsoft Hyper-V using REFS or even NTFS. Okay. So sometimes they also utilize another thing called CSV. This is the cluster storage volume. Okay, cluster storage volume. So another thing on the file system for the operating system. So if you're looking into your virtual machine or physical machine, it will have like ext, NTFS, REFS, okay, ext4, then maybe some other format, okay, in your operating system. So this is on the normal client OS part. Then you have the NAS file system over here. It will be shared either CIFS or NFS solution, okay, using a NAS file system. So the relationship between your files to disk, okay, file to disk. Okay, so your user created the file, okay. So this file can be different in terms of scenario. So it can be a DOC file, okay. It can be a PHD disk, for example. Then it will store into the file system, either NTFS, or if you're using the okay, Huawei, it will be VIMS, for example. Then the file system will convert into a log that write to your particular logical unit number. Okay, so they will basically send the block to your logical location, either a storage pool in your storage system, or if you are using Linux-based machine, your local can be a LVM or logical volume manager. Okay, logical volume manager. So from there, they will further pump the block to your physical location on the disk. Okay, using the RAID configuration, you now able to write to multiple drives within the same group, and then the data will actually write to the disk sectors respectively. Okay, so the disk sectors will be served by multiple drives into a pool, so you can get more parallel processing performance from there. Okay, so this is on the relationship. So next thing will be on the virtual machine disk. Okay, introduction. Okay, so for virtual machine disk, you will see that once you install the virtual machine with an operating system, okay, so you can see from the top view, you can check from the disk management, see what are the disks that is actually mounted to the machine itself, and you can now start to actually format the drive and use it for other purpose like storing data whatsoever. Now, if you are using native KVM without any user interface, okay, from open source, for example, now from the administrator view, they can type in some command to check your virtual disk, okay, image. So this is basically from native KVM. So if you are using Huawei Fusion Compute, you can always check under the VRM Web UI console. Okay, so this is on the virtual machine disk view. And you will see that based on different vendor, they might utilize different virtual disk format, as I mentioned earlier. So VMware will be using VMBK, Hyper-V and Fusion Compute using VHD. Native KVM with QEMU, they will be using either QCOW or QCOW2 or QED. Oracle VirtualBox will be using VDI. Okay, so these are this extension format that is recognized by different platforms respectively. RAW is just a raw device mapping that can support by every one of them. So they will just map like a raw device and then only format the file system to be utilized. Okay, so lastly, we'll look into certain functionality refers in the Fusion Compute solution. Okay, Fusion Compute solution. So in the Fusion Compute, you will have generally a few things need to be keep an eye on. Okay, so first you have the storage resources. Okay, storage resources. So over here, it will be your okay, actual storage system. Either it is a SAN or NAS. storage. Okay, the entire storage system itself. Okay, so from the storage system, I need to connect your VRM and also your CNA to this particular resources. Okay, I need to form a connection to this storage system before I can see the storage device presented to me. Okay, storage device presented to me. So the storage device here, you will see that I am able to utilize LUN, and over here it will be also able to detect your local disk. Okay, things like this. So this particular, if you refers to the Fusion storage, it's a bit different here. So this one will be the volume on CNA, and this one will be the RDM mounted to your virtual machine that I showed earlier. Okay, so if you are going for this, this is the VIMS file system. Okay, VMS file system. Okay, VMS file system will be using it as a virtual storage itself. So this one will be your data store over here. So this will be used as your virtual machine disk location. Okay. So you will see that later only you can create your data store. Okay. So your storage device will be looking into your LAN, your local disk, and things like this. So your storage device will be looking, storage system will be looking into SAN and NAS equipment. Things like this. Okay. So in the configuration lab, you will see all this also. Okay, I will actually demo to you how to add in a data store, storage, and all these things. Okay. So next thing will be the virtual disk feature. So when you are utilizing Huawei Fusion Compute virtual disk, okay, so you can have different types of them. Okay. So over here you will see the types mentioned over here. This is used for okay, individual virtual machine. This is used for maybe 2 VM to share same disk. Okay, so we have two different modes on your VHD. Initially for shared, you have one VHD here. You can connect to VM1, and you can also connect to the other VM. So, okay, so this VHD will be used for maybe cluster application environment. Okay. If you are not planning to use for any cluster application, we normally do not configure shared VHD onto the VHD disk. Okay, so these are the options. Okay, so next thing will be the configuration mode. Okay, so for configuration mode, okay, so for your virtual machine VHD configuration mode. So you have a first one, common. Okay. You have the second one for, this is Huawei Fusion Compute. Okay, to be exact. Okay, Fusion Compute configuration mode. So first one will be of common. Then you have the tick provisioning, lazy 0, and the third one will be thin provisioning. Okay, thin provisioning. So if you go for team provisioning, there will not be no space reserved for VM use yet. Okay. So your space requests on demand when writing. So performance lower. Okay, but your capacity space can be shared. Okay, in the data store, for example. So these are some characteristic for team provisioning, which it is. So if you go for team provisioning, I will not reserve any space for the VM disk yet. The space will reserve when the virtual machine start to write data to the data store. Performance will be a bit lower as compared to the other mode. Okay. But the main advantage here is your capacity free space can be shared by other virtual machine in the same data store. Okay, so this is the main benefit. Now for common, another name here is basically called tick provisioning eager 0. Okay, eager 0. So this one will basically reserve space. Okay, and they will also format or 0 the space before use. Okay. Highest performance, but your space will get reserved first. Okay, things like this. So your VHD creation also slower if you compare to the other mode. Okay. So take provisioning, lazy 0, they will reserve the space. Okay. But they will not format your virtual disk. Okay. So no format and 0 space before use. Okay. So space will format on demand when writing. Okay, when writing. So performance is actually in between over here. Okay. Performance in between. In and eager 0. Okay, or you can call it common. Okay. So the creation speed for the tick provisioning lazy 0, okay, will be faster than creation speed. It will be faster than common, okay, and a bit slower than team provisioning. So these are the few options that you can actually choose for your virtual machine VHD. Okay, common, it will refers to tick provisioning eager 0. Okay, then you have the other options, tick provisioning lazy 0, team provisioning also. Okay, so this is the differences over here on your configuration mode. So for the disk mode here, this one will refers to dependent like normal virtual machine use. If you are going for independent, this is mainly used for catch disk, mainly suitable for virtual desktop infrastructure implementation normally. Okay. So most of the time when we create a virtual machine, we will go for dependent mode normally. Okay, so this is some of the common things that you will see. Now, all these things is quite common. Okay, you will see that your okay. So Huawei, okay, Huawei and also VMware, they utilize this particular disk mode. They also utilize this configuration mode and also this type. So if you understand this concept, you go to VMware, they will actually show the same concept and also same naming. Okay? It's basically referring to the same technology. Okay, so this is the virtual disk feature, okay, available in Fusion Compute and also VMware solution. Okay, so that's about it for the storage topic. Okay, so for today, done on lecture. Okay, so we have another, okay, last 10 minutes for Q&A, for example. Okay. You can also post your question in a WhatsApp group. Okay. So we'll still be online for another 10 minutes for you to have some Q&A question if you need to.
Okay, I have one question here.
Yes.
Yeah, this is David.
Okay, David, yes.
Okay, I'm trying to find out the demonstration that you gave us for the installation of the CNA and the when we start teaching our students,
yes,
are our students supposed to demonstrate the knowledge of that installation, or it will be us doing the configuration for them to use the environment?
Now, it depends on how you prepare it for your student. Okay? I will say that in order for them to learn the entire platform, it is best to start from scratch. Okay? But the limitation here will be how many physical machines you have, which actually reflect our class. You see, because you have a lot of you, we do not have enough server for all of you to practice at the same time. That's why I'm doing a demo to you. Okay? So this question you need to ask yourself whether your university infrastructure, do you have enough server to support all your students or not? Okay, so like our case, because we do not have enough equipment, that's why I show this website. At least you guys can actually play around and have an idea how to actually install that. But the actual equipment, I am just doing demo to you. How close this website and the actual installation is. Okay? So I would suggest you to also provide the server for students to install at least from scratch. If you do not have enough equipment, then sorry to say, you need to go to our method over here. A lot of things you're just able to demo things like this. Okay? So at least for the installation here, because they require physical hardware, after you install already, then when you manage your virtual machine and create a virtual machine, you can actually do it together. Okay? So if your server hardware do have enough RAM, memory, whatsoever, you can now create virtual machine, all these things with your student together. That I will do tomorrow. Okay, but due to the class size here and Huawei limitation on hardware, you guys cannot practice the virtual machine creation with me. Okay? So tomorrow you also see the demo for that. Okay, get the idea? So these are some tips I can pass to you.
Well, yeah, thank you very much. I think it's
okay, welcome. Okay, welcome.
Yeah.